Hello everybody. So we're going to start up a new unit, and this unit is on circles. So in order for us to be able to do too much with circles, we need to know a couple of basic terms. Now, this video is not covering all of the vocab for this lesson. So if you need to know any other vocab terms, I suggest that you go to the vocabulary part of this website, go down to Unit 7 and check out some of the other vocab terms that you're going to need to know. Those are things such as chords, arc, those types of things, okay? So we're only going to go over a couple of those terms today to help out with the problems on the homework, but you're still going to need to know the other vocab for upcoming lessons. So, the basic terms that we're going to work with today are diameter, radius, circumference, and area. Let's talk about diameter and radius right now. Diameter is a type of a chord that goes through the center of our circle. Okay. Now, the center would be the point that is equidistant from the circle itself. Okay, and the circle, what makes it a circle is that all of these points are equally distant away from the center. And we generally name a circle based off of whatever the center point is called. So, for example, if I called this point T, we would call the entire circle T. So the diameter, again, goes from basically one side of the circle through the center to the other side. So that is our diameter. Okay, it is a chord that passes through the center. Radius goes from the center to the edge of the circle. Segment from the center to the edge, or to the circle. Okay, so in this example here, I'm going to highlight this in green. Here would be our radius. Okay, pretty easy stuff. Now, what you should notice, or you should have actually learned this before, hopefully, what you should notice is that our radius is half of the length of the diameter. That's true. Radius equals half diameter. And what's also true then would be that diameter would be twice the length of radius. Okay. Now I'm actually going to be abbreviating radius to a lowercase r in the future. Diameter will stay as a capital D. Okay, so when you see that in the future, again, r is going to be lowercase r instead of a capital R. So the first types of problems that you're going to see is going to ask you things such as this. For each of the following, state what the diameter and radius is. Well, we just have to look and figure out what they gave us, and then either divide by 2 to find radius, or multiply by 2 to find diameter. So in this first example, what you will notice is that it's showing our length stretching from side to side, passing through the center. That, by definition, is diameter. And it tells us in this problem that our diameter is 18 centimeters. So we can write down for diameter 18 centimeters. However, if we want to know radius, we said that radius is half of diameter, so half of 18. Our radius here would be 9 centimeters. Okay? Really easy to do. Let's take a look at the other example on the screen. Here, we're not stretching all the way across. We're going from the center to the circle itself. That is a radius. So we can put down our solution for radius. Here it is 4 inches. But diameter, we know to be twice radius. So 2 times 4, which gives us 8 inches. So basically, the missing piece over here would also be 4 length, and the total length would be 8 inches. So I have 2 more example problems that you can try out on your own. Pause the video and resume when you're ready to check. Okay, so here you should notice that they gave us a radius of 230 feet. So that goes in our radius solution spot. Diameter is twice the length of the radius, so we need to multiply this by 2. That gives us 460 feet. And let's check the other problem they gave us. Here they gave us another diameter, 113 inches. Well, we're looking for radius on the other part, so we're going to have to do what we can to divide by 2. So we want to say 113 divided by 2, which gives us 56.5 inches. How'd you do with those few problems? Okay, I'm hoping. Let's take a look at some different stuff now. Okay. Again, I had told you that one of the terms we're going to be working on is circumference. Circumference is the distance around a circle. Very much like perimeter, but we're not counting flat sides now, we're counting a rounded object, so it's not as easy to just count. We're going to have to use a formula for these. And the formula that you see in front of you, circumference equals 2 times pi times the radius. Remember I said r, little r from now on. So we're going to use this formula right now in an example. They say for us, what is the circumference of a circle with a 10 millimeter diameter? Well, hold on a second. They gave us diameter. Our formula calls for radius. It's not that it's impossible to do this problem, we just have to convert our diameter into a radius length. And if you remember from a second ago, we know that radius is half of the diameter, which is 10. So our radius here is 5. Now that we have radius to plug in, we just have to plug in for r. So circumference equals 2 times pi. Here our radius is 5. Now, let's talk about pi for a second. Pi is an irrational number. That means that it has a decimal that's going to go on forever and ever and ever with no repeating, nothing like that. It's just going to be different digits popping up all the time. And in fact, they have very recently found a couple more digits of pi, but it takes supercomputers to actually find them, the next digits, because there's just an infinite number of them. Okay, so why, if we have an infinitely large number, would we want to cut it down to something like 3.14? We wouldn't want to do that. That's an embarrassment to what pi really is. So let's stick with the whole number and let's just leave it as the form of pi. This right here is a number. So let's just leave it alone. Leave it in all of its glory. What I mean by that is that we want to keep the pi as part of our solution. So the things that we can multiply here are 2 and 5, which give us 10. And let's just attach the pi to that solution, 10 pi. And we're talking about millimeters. Okay, so our circumference is 10 pi millimeters for that particular circle. So again, we're going to leave the pi symbol. We're not going to multiply by that horrible 3.14. We're not going to do that. We're going to leave these problems to be way more accurate. The other reason why I want you guys to start practicing keeping pi here is many of you are going to go on to Algebra 2 or even pre-calculus and calculus. Those courses are going to actually require you to keep the pi symbol because you're going to be using it for things such as sine and cosine and tangent for trig, and calculus you're going to want to try using pi instead of plugging in decimals. Okay, so let's get used to it now, keeping that pi symbol here. So here's a new example that you can try out on your own. Pause the video and resume when you're ready to check. Let's see how you did. This problem says, what is the circumference of a circle with a 26-inch diameter? Well, radius is going to be half of 26. That gives us a radius of 13. We plug that into the formula 2 times pi times our radius, which is 13. Our circumference then becomes 26 pi, and we're talking inches. Really a pretty easy problem to do. Now let's work a little bit backwards here. What if they tell us the circumference of a particular shape and we want to know what the radius is? That's easy to do. We're just going to take the information that they give us and make sure that we plug it into the right spot. What I mean by that is if we look at our formula, circumference equals 2 pi r. The information that they gave us here is meant for the circumference. So we're not going to plug in 82 pi over here for r, and we're not going to just say c equals 82 pi because that's not going to help us. We want to keep the r around. What we are going to do is we're going to replace 82 pi in for c, because that's what c stands for. It stands for circumference. So we're going to have 82 pi still equal to pi r squared. Notice how I still have an r here. I want to solve for radius. So what I'm going to do is divide by 2 pi. Remember, pi is just a number. It's easy to work with. If I divide by 2's on both sides, they go away. If I divide by pi on both sides, they go away. And now look what happens over here. My pi's also get eliminated, and I have 82 divided by 2. So that means radius equals 41, and we said our units is centimeters. Okay, very easy to do as long as you plug in your circumference in for c and leave the 2 pi r on the other side. So why don't you try this problem on your own and resume it when you're ready to go. Alright, let's check this out. A circle has a circumference of 14 pi feet. What is the diameter? Oh, that one's a little bit different. It's asking for diameter now. So we're still going to perform all of this work the same way as the previous example. However, at the end, we want to make sure that we double our solution so that we get diameter. So remember, circumference equals 2 pi r. We're going to take this 14 pi and plug it in for circumference. So 14 pi equals 2 pi r. To get rid of that 2 pi in front of the r, we're going to divide by 2 pi. They eliminate on both sides. We get 14 divided by 2. That means our radius is 7. But we want to know diameter. So if we take our radius and we multiply by 2, we will get a diameter of 14, and we're talking about feet. Alright, pretty easy to do. Hopefully you got that correct. Let's take a look at one more different vocab term. Area. Area is the total square units inside of a circle. But if you think about it, you can't really fit a perfect square inside of a circle because you're either going to be having parts of your square stick out of your circle, or you're going to have parts of the circle that aren't being covered with the square. So no matter what, using square units sounds kind of strange. But we're going to cover ourselves by using this pi again. And again, if we remember to just keep pi there, not use that horrible 3.14, we'll get much more accurate answers. So, our area formula is pi times radius squared. So let's take a look at a couple of examples. This problem says a circle has a radius of 13 centimeters. Let's find the area. Well, area equals pi times radius, which in this problem is 13, squared. Well, that's easy to do. 13 squared is 169, and we're going to keep the pi exactly where it is in the problem and add on centimeters squared. So 169 pi centimeters squared is a very accurate, completed answer. Another problem, you can try this one on your own. This problem says a circle has a diameter of 11 millimeters. What is the area? Well, we don't want diameter, right? We want radius. Well, if the diameter is 11 inches, the radius would have to be half of that, so 5.5. Area, which requires radius squared, so 5.5 squared, we just need to figure out what 5.5 squared is, and that's going to give us 30.25. Our pi never left, and we're talking about millimeters squared. I'm sure that you got that one right. Let's check out a couple of other problems. Now you're noticing that they're giving us area, and we want to find either diameter or radius. It's not going to be any different from what we did with the prior problems with circumference, right? They gave us area, and we know area's formula. And we're trying to figure out diameter, which if we can figure out radius, we can get diameter pretty easily. So we're going to take this 289 pi and we're going to plug it in for A, because that is area, and area is the capital A that we're talking about. So if we substitute that in, 289 pi equals pi r squared, we still have the r that we can solve for, which will eventually lead us to diameter. We're going to have to first divide by pi. Eliminates on that side, it eliminates on this side. We're left with r squared equals 289. Okay, well, to find plain old r, we're going to have to take the root of both sides, and that's going to give us 17. Square root of 289 is 17. But our problem asks for diameter. So if we want to do diameter, we're going to have to multiply by 2. That's going to give us, looks like 34. We're talking inches. Now we don't have to square this because we're not talking about area anymore. Diameter, remember, is a straight line across. So we just leave it as 34 inches. Okay. There is one final problem. Make sure that you check what they're looking for here. They're looking for circumference. So game plan here, find radius and then plug it into the circumference formula. Try this one on your own and resume it when you're ready to check. Alright, let's see how you did. Hopefully you remember that we're going to plug in that number 441 pi. We're going to plug that in for the A part of our area formula and keep the pi r squared. Here I want to divide by pi on both sides. That leaves me with r squared equals 441. We're going to have to take the root of both sides. So we want to do the square root of 441, which gives us 21. But they're asking for circumference. So that's easy enough to do. Circumference equals 2 pi r. We just found r. We plug it in. Circumference equals 2 times pi times 21. 2 times 21 gives us 42 pi, and we're talking about feet. And as far as do we need to square this? No, because remember, circumference is talking about it might be a circular distance, but it's still distance, which is still linear. So we don't need to add the square. 42 pi feet for our circumference. Okay, so that was it for the introduction to circles. There's going to be a little bit more stuff up there pretty soon. If you have any questions about how to find area or circumference or any of the vocab terms, either bring them into class or leave a comment on the website. And check out the website vocab page for any definitions that you might be missing. All right, have a great rest of your day.